Welcome in. So imagine trying to fit a rigid 140-inch wide cinema screen right through your front door. You measure the wall in your home theater or corporate training room, and it fits perfectly. But you completely forgot to measure the stairwell or the elevator and those tight hallway corners.
Yeah, that is a logistical nightmare waiting to happen.
Exactly. So today, our mission in this deep dive is to explore the hidden mechanics of professional-grade visual setups that solve these exact physical constraints. We are pulling our insights from a spec sheet provided by HDTVSupply for the Draper 161-inch profile plus fixed frame screen. Okay, let's unpack this because the logistics of installing a massive architectural monolith drives some seriously clever AV engineering.
It really does. I mean, the physical reality of the building completely dictates the design of the hardware. A single solid piece of equipment that large simply cannot navigate standard doorways.
Right, there's just no way.
So that's why this spec sheet explicitly notes the screen ships entirely unassembled. The foundation is this lightweight frame that sits, less than 2 inches deep off the wall, and it uses a sliding hook and loop system to actually attach the viewing surface.
So it's essentially high-end IKEA furniture for cinephiles. But instead of bolting together a bookshelf, you are using those sliding hooks to precisely tension a massive, pliable material until it mimics a solid, perfectly flat wall.
Spot on. And what's fascinating here is how they engineer the edges of that tension surface. The specs emphasize a zero-edge or borderless option, which relies on these extruded aluminum baffles.
Oh, nice.
Yeah, so rather than framing the screen with a thick black border on the front, these baffles pull and clamp the fabric tightly behind the viewing plane.
Meaning the structural support is hidden entirely in the back.
Exactly. And because there is no front bezel, you can place two screens side by side and the images will literally touch. It creates what the industry calls a mullionless display, meaning there are no visible structural dividers breaking up the visual field.
So the frame completely solves the visual geometry. But putting a massive, tightly stretched drumhead right in the center of a room creates a major acoustic problem. Like, where do you put the speakers? Here's where it gets really interesting.
A huge challenge, yeah.
Right, because if you are dropping $4,506 on this screen, which the source points out is a savings of over $1,000 off the $5,632 to MSRP, shouldn't that surface be 100% optimized for video? Why sacrifice the optics to accommodate the room's audio?
Well, if we connect this to the bigger picture, true cinematic immersion requires the audio's origin to perfectly match the visual's origin.
Okay, makes sense.
So if an actor speaks in the center of a 140-inch screen, the voice needs to project directly from the center of that actor's face, not from a speaker sitting on the floor 3 feet below the image.
Because that would totally ruin the illusion.
Exactly. To achieve that illusion, your center channel speakers have to sit directly behind the screen.
Wait, but if the speaker is behind the screen is physically blocking the sound waves. And looking at the specs, Draper solves this with their ClearSound NanoPerf XT1000V technology, which means the surface is covered in microscopic perforations.
Literally thousands of tiny holes, yeah.
Right. But if you literally poke thousands of holes in a projection surface, aren't you inherently ruining the image? Like, how does a canvas full of holes still support a crisp 1080p resolution?
It actually exploits the limits of human perception. The microscopic perforations are smaller than the human eye's ability to resolve at a standard seating distance.
Oh, wow, really?
Yeah, your brain just naturally fills in the missing visual data. However, those same holes are perfectly sized to let large acoustic sound waves pass through uninhibited. And the spec sheet notes this is a 1.0 gain white surface, which is the mechanism that actually keeps the image looking solid.
Break down that 1.0 gain for me. What does that mean?
So gain refers to the screen's reflectivity. A 1.0 gain means the surface reflects light equally and uniformly in all directions. Yeah, rather than artificially concentrating it toward the center of the room. That uniform light dispersal is absolutely critical when your surface is perforated.
So if it concentrated light too much, you'd see the holes.
Exactly. If the screen concentrated light too aggressively, the microscopic holes would create harsh visual artifacts and hotspots.
So it functions almost like a one-way mirror, but for sound and light. It tricks your eye into seeing a solid, glowing surface while letting the audio breathe right through the wall without muffling it at all.
It perfectly balances the optical physics and the acoustic physics so that the hardware essentially vanishes from your awareness. The ultimate goal of screen design is to, stop looking like a screen.
So what does this all mean? Whether you are mapping out an upgrade to your own AV setup or you just follow the cutting edge of the tech, a truly great display is defined by what you don't notice.
The invisible engineering.
Exactly. The invisible engineering, the acoustically transparent fabrics, the uniform light gain, those mullionless frames. It is entirely focused on removing the physical barriers between you and the media.
Leaving just the experience.
Which leaves you with an interesting final thought to ponder. As these screens become entirely borderless and acoustically transparent, blending seamlessly into the room, will the future of AV design involve hanging physical objects at all?
That is a fascinating question.
Right. Or are we moving toward a world where our rooms are just invisible architectural surfaces, patiently waiting to be illuminated? Think about that the next time you look at the big blank wall in your living room.